end this chapter with last theory and some exam questions. And by the way, your test is live. You can this class. I think so. You have time for next class. Between that, you can attempt or tomorrow. Till tomorrow, 9 p.m. It will be there. Let's see a Carnot cycle. Okay, Carnot engine is just like we can say ideal engine, which gives almost 100% efficiency. So we'll see some condition for that. This is P, this is V. So in Carnot cycle, first one is point A to B. Heat goes here, so that means heat enters. It is isothermal. Now, next is adiabatic expansion. See, this is also expansion. When, remember like this, whenever it comes from P to V, it is expanding because volume is changing, increasing side. Whenever it's going upward, backward, reverse, that is volume is decreasing side. So that is compression side. Adiabatic expansion. So let's name it as C. So same way it will go here. Change of temperature. Adiabatic expansion. It is adiabatic compression. So if it is adiabatic compression, then this will be isothermal compression. So let's give a name A, B, C, then here D. This is your volume change from V1 to V2. This is isothermal expansion, adiabatic expansion because volume is changing, expanding. Here volume is compressing. So here we saw here four operation here. One is isothermal expansion, adiabatic expansion, then isothermal compression and adiabatic compression. These four things only we need to remember. So I'm repeating again and again so that you will remember that. Keep that in mind. So four cycles or four operation of this cycle, we can say. So this Carnot cycle is ideal engine based on isothermal expansion, then adiabatic expansion. After this, isothermal compression, then adiabatic compression. So engine has efficiency. Engine has efficiency. And pump has performance. Efficiency of Carnot engine. W by Q in initial heat. It was Q1 entered. So if it is Q1 entering here, so Q2 will be this side. So mu n or R T1 ln V2 by V1 plus same way mu R T2 ln V4 by V3 divided by mu R T1 ln V2 by V1. So mu R we can cancel it. So adiabatic expression we can write from this one, BC and DA. Those are adiabatic expression. Adiabatic expression or equation. Let's say equation. TV V1 or V2? There is V2, right? Yeah. V2 gamma minus 1 T2 V3 gamma minus 1. So T1 V1 gamma minus 1 equals to T2 V4 gamma minus 1. If we combine this all, this gamma minus 1 and all that will get cancelled. Means T1 and T1, T2 and all this will get cancelled. So we're left with V2 by V1 equals to V3 by V4. So efficiency equals to T1 minus T2 by T1 or Q1 minus Q2 by Q1. Or we can say 1 minus Q2 by Q1 or 1 minus Q1 T, T2 by T1. So this means if you multiply by 100, it will give you efficiency in percentage. T1 minus T2 by T1. Obviously, efficiency should be in percentage form. Same way if you multiply by 100. So efficiency like will not be 100%. It's like less than 100%. So whenever we are using this one, this ratio Q2 will be a little bit lesser than, at least a little bit lesser than Q1. It will leave at least 0.99% of Q1. 0.99. If it is 100, it will be 0.99, like that. It will be little less. So we can write here, make a note of it. It's just common thing. Efficiency can never be 100%. This can, so reason behind this, like if I want to make this 100%, then this temperature, change of temperature should be zero while compression. It is not possible. If it is zero, then there is no compression back. It's not possible here. So it will be less because it's going, even we saw that cycle, where is our heat engine? Yeah, T2. So there should be zero. T2 should be zero. If sink is zero, that means everything is given as output. 100% will be taken as output. Whatever input is given, everything is converted to output, which is not possible. Little bit will be loss. There will be little loss. Never be 100%. You can write as T2 equals to 0, not possible. So for Carnot cycle, Q2 by Q1 equals to T2 by T1. If you can't remember this way, you can remember like this, T2 by Q2 by T2. I'm just replacing this two. T2 equals to Q1 by T1. So one statement we can write for this one. So no irreversible can have efficiency greater than Carnot. And so we say Carnot as a ideal. Carnot reversible, it is also reversible, which is working between hot and cold reservoir. Let's do with some numerical. Can you guys hear me? Am I audible to you? Both of you?
Yes, sir.
Okay. What about Samhita?
Yes, sir.
Okay. Then let's do some numerical. One of the most efficient ever developed between K and its actual efficiency is 40%. What percentage of the maximum possible efficiency is this? Yes. How to start this?
Sir, could you once scroll up? I didn't take a screenshot of the car or not engine part of it.
Diagram?
No, so just the formula, the important formula. Can you just scroll a bit more up? More, sir. Yes, sir. Done.
Yes. Try this. No idea? Anybody progressed anything? Aditi, Samhita?
So can you explain it?
Okay, see what is given here. One of the most efficient engine, which is developed operating between this to this range. This is the range given. Its actual efficiency was 40%. What is the maximum possible? We need to find out. Maximum possible is, we need to find out. So efficiency at max. So if you're taking maximum, so we will take all the maximum value. So this will be 700 will be minimum value. 2100 will be maximum. So 27, 3, 3, 1 are 3 minus 1.66 into 100. So 66.6%. This is the maximum possible. So with this 40%, what is the temperature there? And max with this values. Okay. So this one actual percentage is 40. So if I take ratio of this one maximum to this one, so 40 divided by 66.6 into 100, which can give how much? 66.66 means 1 by 3, 100 by 3, so 100 cancel, 2 by 3. So it will become 220 and it will go 3. So 60 percentage. So 60 percentage is what? Maximum efficiency of this engine. So what I did here, I found the maximum possible and this actual. Maximum possible, like ideal case. This is the ideal case. Ideal case where this temperature is operated between these two. But this is actually maximum is 60%, not 66. Let's take this one. Yeah, understood this one, by the way, this question. Everyone? Clear?
Yes, sir.
Aditi and Samhita?
Yes, sir.
Chalo, ठीक है. So we'll see some Carnot cycle question. Yeah. A Carnot engine working between 300 Kelvin and 600 Kelvin has a work output of 800 joules per cycle. What is amount of heat energy supplied to from source per cycle. So in this one, simple way, if I solve this one, efficiency equals to 1 minus T1 by T2, which is equals to W by Q1. So W is 800. Q1 we need to find out. So 1 minus 800 by Q1, 1 minus T1, how much? 300 by 600. It's increasing. Point 0.5, and this one is 1. 1 into 0.5 is so Q1 is 1600 joules per cycle. They're asking per cycle. Half, 1 minus half is half. So 800 divided by half is 1600. Yeah, this question is good. Monoatomic gas. Can you hear me? I got disconnected. Am I connected now? I guess. Yeah. Chalo. Okay. This question is good. So I'll give you some extra information about this question. It's not in the question, but I'll give you. Carnot's it engine works with ideal atomic gas and adiabatic expansion ratio 2. Determine its efficiency. I'll solve this. Okay, so expansion ratio is V3 by V2 for adiabatic third process from this one. Carnot. V3 by V2. And remember this gamma for monoatomic gas is 5 by 3 and diatomic gas is 7, 2. Five by 3 and now this is what gamma means what? A constant. What constant? Adiabatic index. I think I haven't discussed this one. So like, let me write this. Adiabatic index. So adiabatic index for a monoatomic. Mono means like helium, neon. These two are monoatomic type. And dia means oxygen, something like nitrogen. These are diatomic. Now in this one, these two values, what it represent? Specific heat capacity. Means Cp to Cv ratio. Cp to Cv ratio. This ratios gives us gamma value. Any other information required? Fine. These are some constant values. So if you want to ask any other information also, you can ask. Because when you ask, then only I will just tell more information. Otherwise, I think, yeah, you know this. In this one, phi represent like this one, they have 5 degree of freedom. Means like degree of freedom in a sense, it can move in translatory and rotational. Three translatory, 2 rotational, total 5. It has 3 translatory degrees of freedom. Means motion is talking about movement. Some little extra information. Okay, let's come back to the question. So formula gamma equals, sorry, neta equals to 1 minus 1 by to the power gamma minus 1. So 1 minus expansion ratio 2. So 2 by, this is equals to 2. Value is given, na? Yeah. So 1 by 2 to the power gamma is 5 by 3 minus 1 because it is mono. So it will be, how much it is? Check. Is it 37? Percentage means 0.37. Check, this one is 0.37. Answer is here 0.37. So if this is correct, 5 by 3, 5 by 3 means 1.67. So 1.67 minus 1.67. It's almost half. I don't know. 0.55, 0.55 means more than 0.5. It's yeah, it's coming around 0.5, less than 0.5. Check what you're getting. Do the math. Check. Is it the same answer? 0.37. Aditi, Samhita, tell me. Okay, done. Aditi, Samhita. Okay then. See you Monday. Bye bye everyone.